that this red line is tracing the requests different clients are making to your server. And you'll see that most of the time, your server processing capacity is well above the requests being made to it. But occasionally you get these peaks where you'll get a lot of requests at once, and that's going to cause your server to fall behind in its processing capacity, which means you can't serve all your clients, which is obviously bad. So the question you have in this scenario is, okay, how do I make up this gap? And so the simplest and most naive solution you might come up with is, okay, let's add more capacity to the server, right? We can just buy a bigger server. And you're right, that will work. It will solve the problem. And on top of that, the pros to this is now you won't have to do any code changes. So what's wrong with this? Well, there are a bunch of problems here, right? If you just naively increase your server capacity, you'll notice like there's a lot of wasted capacity, right? All this area, right, is representing server resources you aren't utilizing. And that costs money to maintain and run. So you can see that you're going to have a hard time with having a cost-efficient solution this way. And furthermore, you're going to have to keep monitoring like the top capacity level. And if that capacity starts to increase what your server can handle at a time, you'll have to buy yet another bigger server. So you can see that this is a simple solution, but it's a very inefficient solution. Okay, so idea 2, right? Go serverless. So if you don't know what a serverless function is, it's basically a function on demand or some compute on demand you can purchase from a cloud provider. So AWS Lambda or Cloudflare Workers are examples of these, right? And the advantage of this, right, is, okay, once again, if we're using this to solve our compute, right, it solves our problem. So we're always going to have enough compute to meet our capacity. And it's going to be really efficient, right? Because since we're ordering compute on demand, right, we're always going to get the exact amount of compute we need to solve the problem. So that's really great. But what's the problem here? Well, the problem is a couple things. First, you have to pay for cloud services, which if you're not already paying for cloud services, that's a big hurdle to jump through. You're going to have to set up infrastructure, permissions for all of that sort of stuff. And on top of that, you're going to be paying a premium because that's how cloud service providers make money. On top of that, you also have to worry about the fact that when you're calling functions on demand, if you're not calling them frequently enough, there's going to be a time delay for those servers to spin up originally. So you're going to have to pay the time for the network cost, which can cause your users to maybe experience some lag. So this is a good solution in a lot of cases, but as you can see, there are reasons why it's not a perfect solution. Idea 3, use a combination of microservices. So in this case, it's more ambiguous what our actual compute capacity is if we're using a bunch of different services. So instead of having this monolithic application with all our code in one place, we'll say, okay, let's split up the different aspects of our code into these little chunks. So that way we can be more efficient and have them communicate that way. But there's a disadvantage to this in the place that it's going to make it much more complex to have our application work with each other. All those services now need a way to communicate. So there's a lot of complexity we're paying for this solution. So I think this isn't an optimal solution to solving the original problem, where we just had some workload that initially exceeded our capacity. So is there a different approach we can take? And so I think Zucchini, which is my senior project, is an answer to this. So the benefits of Zucchini is it's easy to drop in without requiring architectural changes and minimal code changes. So what Zucchini is it's a library in Go, which is a programming language, especially geared towards backend and systems development. And this is a lot of the case. This is what you would typically run your server in if you were doing some sort of high performance web server. It's a very common language, so that's why I chose Go. And it's built on top of Go's own asynchronous primitives, which is Go routines. So it's able to very efficiently utilize those to be able to execute tasks running in the background for a long time. You're able to achieve minimal communication overhead by using Redis, which is an in-memory sort of key value store. And it has additional features to simplify task management, such as if you have a task that you know, okay, this might fail, I want to be able to have some sort of strategy for how to rerun this if it fails, like I want to have exponential back off and how long I'm waiting before I retry this task. It will make it very simple to configure that. And on top of that, it has a relatively simple API to work with. So what I've achieved with Zucchini over this term is you can now download it from GitHub. It's an open source library. And these basic APIs, which will allow you to configure and run a task, are all working and available. And I'll show a little code snippet of what that might look like later on. So here's like a high level overview of how Zucchini works. So you have a client or multiple clients like we saw before, and they are communicating with a set of Go processes. So those Go processes, right? One Go process is going to be responsible for executing the tasks and then streaming the results back into Redis, while the other Go process is going to be able to handle dealing with the client long term. And the way Zucchini works is it adds an abstraction layer around dealing with Redis. So instead of having to manually serialize the task results into Redis, check Redis for the task results and configure that, you're using a high-level API, which is something like, hey, here's my function in Go, and I want to give this to Zucchini. I'm going to pass it in. I'm going to have maybe some configuration around that. And then what Zucchini is going to do is it's going to handle executing that in the background and then having the results saved in Redis and then pulling Redis for the results. And you're able to specify, okay, after this finishes, and after I see that my results in Redis, I want to do X thing with the result. Maybe I want to save the result to a database. Maybe I want to use the result value of whatever task I have and send some sort of automated email to let a user know, hey, this finished, you're signed up maybe. So here's a high-level example to motivate it. Say I have some sort of image sharing site. Say I want to upload this cat image, and I'm going to have some sort of server, and I want to have some tagging service I'm going to call externally that's going to use AI to do image detection, tell me, hey, this is an image of a cat. So if people want to search for like, hey, what are cat images on the site, it'll be easy to do that. And if you wanted to use Zucchini for this because you thought maybe at some point people are going to load a lot of images all at once, here is something about how the architecture might work. So you see we have the upload that goes to the initial Go process, which communicates to Go process 2. Go process 2 runs this task in the background using it like Zucchini task. Calls the external image service, then those results get serialized to Zucchini, and Go process 1 defines a callback function for the result of the task, which gets saved in the database perhaps. Otherwise, you could have this Go process do something else when the task finishes. Say you want to let the user know that their image finished uploading. It could send an email to the user. It's really a flexible system for how to coordinate and configure tasks. So there's no hard limits to what you can or can't do with it. The general pattern, though, is that you're going to use multiple Go processes, and one Go process is going to act as a consumer of tasks, and one is going to act as a producer of tasks. So really quick, here are some code snippets for what this might look like. It doesn't matter if you don't understand anything completely, but the basic idea here is we're going to show what a producer might look like. So these below are real APIs that are currently working right now. So this is how you would define a task, right? Which is you're going to define a task as some sort of combination of function and arguments. Maybe in the future, I'm going to add more configuration, so you'll be able to add like failure behavior. And then you have a queue, which is another logical abstraction, which is just a collection of tasks, which is connected to a single Redis instance right now. And you can enqueue that task. And then in your consumer, right, you'll be able to register a callback for how to handle the results of those tasks once they finish. So in this case, we're checking if this result succeeded, then maybe I want to have some function which is going to update the image tags with that result value. Otherwise, I can have some error handling logic. In this case, if for whatever reason the tagging failed, maybe the site was down, maybe I want to use this to retry. Maybe I'm going to send some sort of alert to the user. Maybe I'm just going to log, oh, this failed, and then give up. Whatever you want to do, Zucchini is flexible and is going to be able to handle that. So those are the main features I've accomplished as of now, and I hope that gave you a good idea of what I'm trying to accomplish. Questions?
Thank you, Addison. Any questions for Addison? Okay, I have a question.
Yes.
So what is there any overhead if I have a bunch of small jobs versus one big job that you can split?
Right, so there is going to be a constant overhead. The amount of jobs doesn't matter as much as the initial cost of, okay, I have to constantly be pulling from this source to check, okay, is a job finished? And then there's the serialization cost. So in some ways, if you have multiple smaller jobs, you might get more bang for your buck than if you're just offloading one big job. But they're depending on the number of jobs, what scales linearly with the number of jobs is the cost it's going to take to like serialize the results. So it's a partial trade-off, I would say.
Okay. Good. Any other questions? Okay, thank you, Addison. Our next speaker is Yicheng and Chinyi.
Hello, good morning, everyone. My name is Yicheng. This is my partner, Xinyi, and we are developing a portable device to help the shelf checking process in the library. So you might know, like Trinity Library do have like millions of books and materials and whatever in the collections. And one of the biggest collection, they have to take care of the book orders so that it is accessible from our from other users and or student staff. The society to like get easy access to it. And do you ever wonder how that process would be? So here are some background knowledges. The library use Elma, Exliver's Elma, which is a cloud-based material management system, which can track all the transactions that we loan out to return in and add of new books in the system. We will be having those images showing what is the back end of the Elma look like. Also, the books themselves do have two identifications on it. So this is a school book in Trinity Library. If you can see, there's a sticker over here and another sticker on the back on the front of it. So one of them is a barcode, which is 1-to-1 correspondence to each book, but no two books are sharing one barcode, and the other one is called call number. It is a Library of Congress call numbers, which is a standard used here. A lot of schools use it. It has some useful information in it, so you can by looking at it, you will know like this HJ is a public finance book. So the process of going to the shelves and make all the books, put in the right order and check if they are in the right order are called shelf checking. And it's performed by the student workers working in the circulation desk, help desk in the library. They're all student workers. Sometimes they go into the shelves like every week. 2 shelves are assigned to them. They go in there with their laptop, have a spreadsheet, Google spreadsheet over there. And the spreadsheet says what the call number of the book, what the order should it be, and what's a barcode. You go in there and look at the books. Okay, the first one is there, the second one is there, the third one is there, and you check, mark all the. So you see here on the second column, on shelf, YMO, you mark it. If it's in place, mark it as Y. If it is missing, mark it as M. It's out of place, mark it out. But there are some, like, you might notice, like, it might be a very exhausting problem solving that, like using the current method, because first bringing a laptop to the stacks, where do you put the laptop? You might like have it in the hand, or you might find this like a gap in the stack to place your laptop, but like it might be not so convenient doing so. So we are trying to find a better solution for it. So our solution here was to build a system based on like a Raspberry Pi microprocessor and with software on it to have a handheld device to help the students to do the shelf checking. Also, another problem with the shelf checking by the student was some of them are not very experienced with the LC call number. That means if they go in there and mess up with the stack itself, it will be worse than current station. So let's look at, like, for example, this is whatever you will expect the order of the book. If you want to find D book, you will go in there and go find B. D, you will know it is between C and E. So it is an easy find. However, like it is not always like that. Sometimes there are books, your shelf could look like that. You want to find D and look for C, but D is not right after C. They might have a like more like distance between them, so it's not like this narrow here. And also there can be some books which are out of position on other shelves. So what the student workers are required to do is they go there and fix those books that are not in place and return those books are missing. So our solution do have a significance that like eliminate human error and save time and energy and can migrate to other systems. So you might want to ask, like, what does our solution look like and what does it do? We might have we are having a small introduction of it.
Our whole system can be roughly divided into 2 parts. This is the hardware part. It has the main part of the hardware is the microprocessor called Raspberry Pi, and it equips with the touch screen to make it convenient to operate and read. And also we have a barcode scanner. It can scan student ID and the barcode on the books. Also, we have a portable charger to provide power and the SD card to store the whole system. And this is the software part. It is operated using Raspberry, and our program is written in Python, which is running in the Sony IDE, and here's what we have done.
So now we have a small demo of what the program will look like. So without introducing it previously, so this is our thing powered with with my computer right now, and I set the resolution to be like a lower resolution to help you figure out. So first, the login page, we want to have the login page to track who is the student who's doing it, and after entering your ID number, which you can do that by scanning your ID card and click OK. And here you go to the shelves, scan the first and the last book, and it will communicate with the Alma server to get a list of books of whatever their order should be and store in the RAM. And then I actually hard code this, and but for now, in the future we will be able to get the real-time list by scanning the first and last book. So for example, the book we are looking for right now, so this should be the first book on the shelf, and we're looking one direction, from the left to the right, from the upper shelf to the lower shelf, and can scanning the books. Okay, so for example, this book is our first book, so it is not the Off the Road with FDR. What you do is you click clear, and you scan in the book, and you submit, and we will jump to the next book. So, but the next book might be on the shelf. I will pretend every other book is on the shelf. So we will find book find and book found every other book showing the information. And whenever it reaches wherever this book should be located, it will show an alert. Because we scan in, it will get it put out, and this book should be placed back into the shelf. And submit. No more books on the shelf, and that's it. It will generate a report for our to analyze in the future. And
Any questions?
yes, to conclude, we're happy to.
Gabe?
What happens with like the first book on the shelf is out of order, and then when they scan it, then like,
Yes, that's one scenario which we might be encountering. And while scanning the first book and the last book, we'll be we will be getting a list, right? And by analyze, the list should be at about 200 items in it. If it is like not in the range, it will give a response. For example, it is out of order, you will know by but we assume that, yes, right now. Yes, sir.
So, so apart from getting the reports from the device, so what about is the student worker or someone who's using the device, are they supposed to do something as let's say now order to putting the right place on that at the same time, or?
Oh, yes, the student worker, yes. Without, so you go into the shelves, get the shelf, you're supposed to get the shelf cleaned up and put the things right in order. So when you leave the shelf should be in a ordered situation. Yes. And our software is helping with that process. It can be 100% autonomous, but we're helping students with experienced student. You can not use it, but I mean, you're not required to use it, but for the inexperienced students, it might be a help to make your job more correct, acting more correctly, or saving your time by going backward and yes, perfect.
So is one of the functionalities we're gonna continue scanning one after the other, and it's gonna tell if a book is out of order?
No, it's so
So say we scan A, B, C, D, and we find F, or say we find Z instead of F. Will I get an error or something that it's out of order? Please rearrange or something like that. Is it one of the functionality?
Oh, it is. It was not the one of the functionality, because we might be encountering a lot of errors along the way. But we only want to go once. We want to go at smallest time as possible, going back and forth of the shelves.
Okay.
So if you're going to scan all the books in, we can do that. So if you want to do that, you can do that. But sometimes it is just very self-explanatory because you can see the book title, so you can just click found.
Okay, I see.
It is basically, the function is basically scanning all the barcodes in, but you can also override it by using the found button. Yeah.
Thank you again. Next up is Helen. The presentation should be open.
Yep. Hi, everyone. I'm Keelan McNamara, and I'd like to introduce you to RISE, a recovery intensity strain evaluation application meant for iOS devices. And it's going to provide advanced fitness data to help you rise above. So the idea from this project came out of my love for staying active. I know many in the room, whether you consider yourself an athlete or not, have hobbies that get you outside and moving. I'm a student athlete here at Trinity, and I also have other hobbies like running and walking and swimming. And when I'm doing those activities, I'm also a data-driven person. So I like to see kind of how my activities are coming out of, are producing data. So that's usually why I wear an Apple Watch. I wear it all the time. I know other Apple Watch users probably wear it, you know, right when they wake up and right before they go to bed. But what I noticed with these data points that I was getting, like the numbers of miles that I was running or the calories that I was burning, is it just gives a very small overview of your overall fitness, where it doesn't really tell you how this activity is affecting the next workout or your next sleep or your recovery time. So I wanted to give a more in-depth analysis of these fitness points using the Apple Watch. Rise won't be the first app to try to attempt to do this. There are many other fitness brands and devices and equipment that do it the same way. The Whoop is a fitness tracker. Peloton has equipment and apps that will tell you kind of the same different metrics and analyze in-depth fitness data. Rise will be using the Apple Watch and the same, which has the same technology as the Whoop. They use green photodiodes. If you wear an Apple Watch or any smartwatch, you'll see on the back there'll be these photo detectors, and they track the volumetric pressure in your blood, which is going to pull heart rate and then get those more analyzed metrics like calories burned and heart rate variability and things like that. But what set Rise apart from these any other apps is the price tag. So Rise will be completely free, and Peloton and Whoop are synonymous with really high price tags. Right now, the Whoop is going for about $30 a month. So for as long as you use it, you'll have to continue to pay, as well as Peloton. Their equipment is around $4,000 with a $40 subscription just to use it. So the main metrics that I'll be tracking again will be recovery, the workout intensity, strain, as well as an evaluation of these three metrics over a week's worth of time. The software resource that I'll be using will be the Health Kit, which is Apple's health database. Anytime that you're wearing your watch, that data is being written to this database and can be displayed for all iPhone users in your health app. I also will be using Swift, as that's the Apple's developmental software. So the calculations that I'll be doing and that I've researched and done and figured out over the course of the semester. So first, recovery, we'll start with using the user's inactive hours. So unfortunately, I can't use heart rate data for finding the recovery, because as Apple Watch users know, or any smartwatch users know, you're going to have to charge it at night. So you're not going to be wearing it and it's not going to be picking up heart rate data. So it would be inappropriate to try to pull heart rate data when the watch is on the charger. So it'll go by inactive hours, and that's found by phone activity. So if you go into your settings, you can see this screen that will find when you first picked up your iPhone, as well as all the different pickups time. So I'll be querying that information to find when the user is asleep. The user can also put in a sleep quality assessment. This is just on a 1 to 10 scale, 1 being about 10% of the night you're asleep, 10 being 100% of the night you're asleep. And these two will be combined together and then compared to an overall sleep standard, which is around 7 to 8 hours, depending on how active you were the day before. More activity the day before would mean more hours of sleep needed to get a full 100% recovery. Workout intensity. This starts with heart rate samples that are pulled directly from the workout. Here's an example of a workout that I've done and all the heart rate samples that have come from that. They're queried about every 5 seconds. So you're getting around hundreds to thousands of heart rate samples for one workout, depending on the length. These heart rate samples are then divided into heart rate zones based on intensity and the percentage of the max heart rate that the heart rate is at. And this will give, each zone has a certain points equated with them. The more points you have, the more intense the workout is. Then a logarithmic scaling function is applied to that sum of points that you get to scale and map the sum to a 1 to 10 scale. So to visualize this process a little more, here are the heart rate zones that I have, and this is the percentage of your max heart rate. This is a personalized max heart rate to your own health data. The Peloton uses a very similar scale, but what they do is they just use an age-based max heart rate, which, as we can all know, I might be the same age as someone, but have different health conditions, different fitness levels, a variety of different things that may change our max heart rates. So what RISE does is it queries your last 6 months of heart rate data, filters through it and finds the max heart rate. That way you have a personalized max heart rate and your heart rate zones are specific to you. Each zone has a certain amount of points with it that will be multiplied by the minutes spent in each zone. And that will give you your total amount of stress points. Then a logarithmic function is applied to those stress points, which maps it on an easy to read and understandable scale. So more about this logarithmic function is that what I did to kind of get these total stress points to be mapped on a more readable scale was I took a 5-level intensity, is what the CDC recommends as about 30 minutes of moderate activity. And then a 10 is 30 minutes of around very extreme intense working out, as well as a 1 would be around a light 30 minutes of light work. Then the logarithmic function of best fit was found between these 3 points, and this will be what's used to map those total stress points to the displayed number. WHOOP also uses a logarithmic function, and this is because that the progression from a 1 to 10 scale is the more you increase your intensity, the harder it is to increase. So if you're working really hard, it's really hard to continue to work at that pace or even increase your intensity. When you're working about at an 8, it's really hard to get to a 10, whereas if you were working at a 3, then it'd be a lot easier to get to a 5. Next is strain. Strain will just take the workout intensities and then times where your heart rate's elevated. So this could be times where you're not logging workout, but walking upstairs. Maybe you're giving a presentation, maybe you're really stressed about something and your heart rate begins to elevate. The watch will notice that and detect that, and then will be applied to the workout intensity scale. Inactive hours will be subtracted from strain. So when you're sitting down for a long time, those are times where your body's recovering. So that will take off from strain. And then it will be displayed as a 0 to 10 scale, which is easy to read and understand for viewers. Here's the current progress that I've made in my UI and app development setup. So first the app is going to load. Right now I'm working on execution time. So it takes a few seconds to load up the app and to authorize your health data information, but that will pop up shortly. And then here you can see all of the data that the app will use. This allows the reader or the viewer to kind of trust the app. Here's the sleep quality indicator where you can set your sleep quality for the night. Then I have my intensity. I have 3 heart rate readings: resting, max, and current heart rate. Takes a few seconds just to kind of load through all those results of the heart rate, and a strain and evaluation tab for further progression. So my current progress of what I've queried and been able to get from the user is the last 6 months of heart rate data, the resting heart rate, all of the daily workouts specific to that day. So not all of the workouts you've ever done, but just the workouts within the last 24 hours and their times. And then from those times, I've been able to find the heart rate samples that go directly with that workout. What I've calculated is the personalized max heart rate, as well as the heart rate zones. Up next, I'll just need to find the minutes spent in each zone, which will sum to the total stress points, and then apply the logarithmic function to find that workout intensity. Future work will also include implementing the recovery algorithm and making sure that the UI is easy to understand. Also, the user can edit their inactive hours. So say you put your phone down and didn't use it, but stayed up reading a book, or you were up in the morning without picking up your phone. You can edit those inactive hours and edit your sleep quality as well. Strain algorithm will need to be implemented as well, and the UI too. Then lastly, the evaluation tab will be focused mainly on data visualizations. These are all charts pulled from the health app, and that will use the Swift Charts API, which allows you to build charts directly in Swift using the data that and the metrics that I've calculated before. This will require me writing data back to the health kit, not just reading it. A timeline, right now we're on December 14th, and by the end of the month, I'll have implemented the intensity algorithm. I'm planning to have all of the calculations complete by February 19th, and then the rest of the semester will be used for, again, focusing those data visualizations on the evaluation tab, testing and tweaking the calculations to make sure that the results are accurate, implementing UI design improvements. And then lastly, if I do have time, I'd like to create an Apple Watch display app that displays the 3 different metrics. That way you can see it not just on your phone, but while you're working out as well. And thank you very much. If you have any questions, I'd love to. Yeah.
What is taking so long for the app to boot up? What do you think is the reason behind that?
So right now, the how long it takes to boot up is the process of all the queries are happening while the app is trying to boot up. So it has been a little tricky with the execution time. I'm not exactly sure what's happening with why the authorization is taking a little while to go. But a lot of it has to do with the queries are asynchronous, which I've learned through the process. So they're happening while the app's booting up, and for some reason it's just working, it's not working, smoothly yet.
I have a question.
Yeah.
To compute intensity, you have stress points. How do you calibrate? How did you give like 8 for vigorous?
Oh, okay, so I'll go back to that slide. They were calculated based on how hard you have to work to get to the next point. So, and going from an 8 to extreme would be around 8 times as harder. And these were based off Peloton's own stress. This is what Peloton does for their workout, but I tweaked it a little bit to be what made more sense for viewers to see, so they could easily see where their heart rates were, as well as personalizing that max heart rate zone. So there's taken directly from other research.
Okay, thank you. Any other questions for Helen? All right, thank you. Our next speaker is Noor, but I don't think she's here. Dheeraj is going to be speaking next, followed by, all right, let me just pull it.
Morning, everybody. I'm Dheeraj Ganji. I'm going to be talking about my senior project, which is titled Anomaly Detection for Cybersecurity. So I'm going to start off by talking about what the problem is. So the problem I'm going to be dealing with in this project is network traffic threats. So we've all been hearing a lot of news about network threats, DDoS attacks, all these big attacks happening. They already cost us $6 trillion in damages annually. That number is expected to blow up to 10.5 trillion in 2025. There's a lot of assets at risk that I mean, as our society moves like towards a more technologically dependent one, we have more and more assets at great risk, and it is necessary to be able to protect these assets. And well, one thing that we need to do is, I mean, these attacks are going to happen, but like one thing we need to do is detect these attacks before they happen. And that's what my project wants to deal with. Quick background about what my project is. So it's going to be an intrusion detection system. So intrusion detection systems are already employed in today's networks. So quick example, this is how a regular network looks like. So you have your internet, and your connections to your servers go through a firewall. Once they pass all the rules of the firewall, they go through an IDS. Now, it's basically like a system that detects malicious traffic. It doesn't take any actions to prevent them, but it detects them and reports them to a network manager or an authority. And there are two types. One of the types is called signature based, as in incoming traffic is studied compared against a database of known malicious traffic. And then if somebody feels off, just tell the network manager. But the problem with that is there's just so many new attacks happening every month, like every whatever time frame you put in. So it's hard to find all attacks on all signature databases. So the type I will be looking at is anomaly based. So an anomaly-based intrusion detection system is usually a machine learning method that is trained on an aggregate of network data. So it's trained on a lot of regular everyday traffic and attack traffic, so it can detect these anomalies in data, like any behavior that seems different compared to like the baseline of regular normal traffic is called an anomaly. And whenever it detects these, it can just go and inform the network manager or the supervisor. An example for this would be multiple incorrect password attempts. So say, for example, you're running a website and you see a lot of incorrect password attempts for one account in like a short time frame. You know there's something going on. So maybe somebody's using like a brute force password cracking method. That'd be an example of like an anomaly. So my approach is even anomaly detection, anomaly data sets that ML models and other IDSs use are limited to data from past events, as in all of this data had to have been collected from some server that was sitting there that might have been attacked. You take all that data and run your model on it, and then you do your thing. New attacks could evade IDS because we never know. Maybe the definition of an anomaly for one model doesn't include this new kind of attack. So the approach is to create a GAN to generate attack info as the attack information generated by the GAN will be something that is new, something that hasn't been seen before by any of the existing IDSs, and also to predict and provide attack classifications in simple language. That's something that a lot of IDSs don't do. It's all very high level black box stuff. So yes, this will be the main goal of my project, and I'm using Python libraries such as scikit-learn, AutoML for baselines, TensorFlow and Keras for the neural networks, etc. So before I get into the data set, I just want to run through what quickly what a cyber attack is. It's an assault launched by cyber criminals. Most attacks try to break an organization's confidentiality, integrity, or availability of any information. Motivations can be a lot. They're usually financial gain, but they can also be political. They can be recognition, corporate spying stuff. And most communications happen over the internet nowadays, which wasn't built with security in mind and is a very public and exploitable service. So some common cyber attacks that most of these are actually talked about in the data set as well. So the first cyber attack is a port scan attack. This is like the initial attack attackers do to probe a network and scan it for vulnerabilities to see where to take their attack next. The second one is a DDoS attack, which stands for distributed denial of service. Basically, using some methods to shut down a server and make it not do what it's meant to do. SQL injection and cross-site scripting attacks are web application-based attacks where you craft special inputs to make the web app do something it isn't meant to do. Phishing and malware is basically software that claims to be something else than it is. So it might be like software that advertises itself as something you need, but actually in the background, like it's actually doing some malicious activity. And cryptojacking is actually when a cyber attacker uses your computer's resources to mine crypto and send it to their wallets. So the data set I'm using for this project is called the CIC IDS 2017 by the Canadian Institute of Cybersecurity. It has 14 different types of attacks, unique types of attacks. I've concatenated, mixed similar types of attacks together, and we can see that DDoS attacks are by far the most popular because in real life as well, DDoS attacks are some of the most large scale and most seen attacks on organization networks nowadays. And it has extensive information. So it has 77 different features. They're divided up into information about TCP flags, port information, like the destination port of the server that the incoming traffic wants to talk to, packet transfer as in like flow information, how fast it's going, what was like the average packet size for this transaction, etc. A lot of information. So before we could do anything with the data set, I had to pre-process the data, completely understand the information, understand each of the features, learn more about the specific attacks that are going on. The data was scaled using scikit-learn's min-max scaler, which scales columns of data between ranges that you provide, but I provided 0 to 1. So everything was scaled to facilitate the learning of the models. Manually removed infinite values and other incompatible information, such as strings, which would make the model not function. And yes. So the problems with the data set was, as I said, it's a very large one. It has 2.8 million data points, consisting of both attack and benign data points. And there's class imbalances. I think for every single attack point, there's 6 benign points. So yeah, a huge class imbalance that leads to complexity of model. So to reduce some of the damages from that, I ran feature selection to see what the features with the most influence on the final accuracy are, the accuracy metrics are. So this is like a quick graphical representation on how feature selection works. So you take all your features. There's 9 different types of methods that were used, but for example, let's say one of the methods was regression. So you try different, I had to try different features and see which of them contribute to the final accuracy the most, and then select those. So in my project, I was able to narrow it down from 77 features to 18 features. And here are some of the feature types that show up in the top 18 features the most. The most common one was idle time. So there's multiple different features relating to idle time, as in like there's idle time maximum, minimum, average, standard deviation, a lot of different features. So the idle time is the time in milliseconds that the connection was left idle. This is a very popular form of this is actually used in a very popular form of DDoS attack known as SIM flood attack, where connections are left open for as long as possible. Like attackers send connection requests from multiple computers, and these connections are left for open for as long as possible to make sure that other users can't use it, effectively causing a DDoS attack. And a backward packet length length type was a big feature type. So actually, that also relates to this, the down up ratio. Typically, one feature that affected most of the attacks was the server was sending more data than it was receiving. This is also a sign of DDoS attacks, where attackers will try to send out as little information as possible and make the server do a lot of work. And when you distribute that and you have a lot of malicious users querying the server for this information, the server has to send out these big packets of information all over the place, thus causing a DDoS attack. And destination port was also an important feature type. Of course, our attackers attack some of the most used and In some cases, some of the most insecure ports such as 53 DNS. There's a lot of DNS attacks that happen. HTTP and HTTPS, I'm sure we know about. And 123 is NTP. And that's the network type protocol, and that is also susceptible to DNS attacks. And SSH and FTP are in this data set, SSH and FTP aren't for DDoS attacks, but they are for brute force password and username enumeration. So yes, those were also some of the most common destination ports. And TCP flag counts was also a big feature. Super quick. So I also ran some baseline methods on the AutoML package. And upcoming work will be to work on a GAN model to generate network threats and explain these threats, try to explain these threats in human language. Thank you.
Any questions for Dheeraj?
Cool project. I was interested that you're using a GAN for this. Is that, because naively, I would think you would just use some sort of like classifier. Is that something typical, or is that like a newer approach people are using?
That's the approach. Actually, that's one of the things about the approach, because one of the things that I'm trying to do with this project is to generate attack types. Because like I said, the data sets are usually limited to real life, like past event data.
So is the GAN like related to like trying to like generate like human describable attack types, or are you generating like network traffic for like here's more training data?
Generating network traffic.
Yeah, it's interesting.
Any other questions? All right, thank you, Dheeraj. We have. I just put everything up. Can you get one on the schedule? Just put all the presentations. Are we doing this? Yeah. No. The one.
The cookies on the
Yes, I just want to get everyone's. Thank you. Please grab cookies. Let's take 5 and grab as many cookies as you can. I just get everyone. You guys can get cookies as well.
Thank you. Yeah, maybe yeah.
Some sugar for the to manage before the talk. All right, we can start it now. Okay.
There was a quote, wow, I was almost gonna go up there and like down. I drank it outside, so it was full off now.
Yeah.
We all here? Hello, everyone, and thank you for joining us today. We're very excited to present you guys with our workout tracking app that we're calling Lift Ledger. So the idea behind this app was this summer when me and Max are trying to think of what app we wanted to create and what idea we wanted to do for our senior project. We were talking, and one issue that we both found was we both enjoy working out, but we didn't have a good way of kind of tracking our workout and tracking our progress. I was using the method where I was trying to remember everything. I try to think about how much weight I was using last time, what workouts I have to do, and obviously you're never going to remember everything perfectly. You're always going to forget.
And for me, having played lacrosse at both Boston University and here, working out has been a very big part of my life, and thus having to track my workouts to make progress and whatnot. And I've been using pen and paper. We use it here in the school gym, and I use it at home. But a big problem with pen and paper is that you can lose the pen or the paper, not allowing you to track your progress, or it could get wet and smudge what you've written, or there's not a lot of smooth surfaces to write on it. So there's a lot of problems when using that. So our project is created as a web application by using MeanStack, which we will explain what MeanStack is later on in the presentation. And it solves a lot of problems in the real world currently. For example, our app is free to use. Maybe some people don't have a lot of money that they are looking to spend on a workout application when taking in gym membership fees into factor. And some of our key features, it allows users to create a workout, a new workout that they want, do a workout that they have already created or that they have downloaded from other sources, and view their past workouts, allowing them to track their progress. So some real world application, I talked to my strength coach here at the school for the lacrosse team, and he brought up a few good points on why this application would help our team, for example. And in the summer, we get workout packets and we get them via email, and we have to print them out and write on them. But like I said, with pen and paper, that's not a good solution. And this will help aid athletes in tracking their workouts, allowing them to gain progress throughout the summer to come into school ready to go. And it also helps with accountability and motivation for the teammates, because rather than maybe saying, oh, I lost my workout packet, it keeps you accountable and makes it out there for everybody to see, which also motivates teammates. You don't want to make less progress than somebody else did, especially if you're fighting for the same position.
So what does our app offer? First is the ability to track workout, like we said, which is huge when you're trying to make performance, especially as an athlete like Max is. Is also an organizational tool for those coaches and for yourself, just be able to look back and see what workouts you've been doing, how hard you've been working. And finally, it's budget friendly. Like she said, that's a very expensive alternative, but they charge $30 a month, which isn't realistic for college students and young professionals. So it is built on the MeanStack framework, which is a very dynamic web application for building web apps, because it doesn't require a huge amount of computational overhead, because our app doesn't. It is on the front end, you have the Angular JS JavaScript framework. On the back end, you have MongoDB, and you have Express.js here in the middle, which is going to be the back end of Angular, and it's all connected using Node.js. And it just enables very dynamic web application. So the methodology for our database and how we're actually going to be kind of operating this thing is we're going to have an array of workouts. Workouts are objects that are going to be, or there are arrays of objects which are going to be made up of exercise objects. So inside each workout object, you're going to have your exercises, which are going to be squat, lunges, treadmill, etc. And these are objects that are going to have fields based on what the exercise is, because clearly reps for a treadmill wouldn't make sense, and incline for squat wouldn't make sense either. And then when you go to actually create a workout, it'll create a carbon copy of this workout object where these fields are blank and allow you to input them. Thus, you're not editing the actual workout, you're just editing the copy that you make of that workout. And then all those workouts will be stored in another array of workouts. That way, that final workout array will then be the one that we analyze and allow the user to track their progress and view from the past.
So some of our progress and challenges, learning JavaScript, TypeScript, and HTML was both progress and a challenge. It was a challenge because neither of us have created a web application of any sort, and it was new to us. But at the same time, it was progress because learning a completely new syntax was a good step towards the direction that we wanted to go. The second part of progress we made is we sat down and we designed our application. We drew out how we wanted the front end to look, how we wanted all of the different aspects of our project to connect and talk with each other. And then we started actually coding and writing our front end on Angular and kind of getting the rough draft of exactly what we wanted the front end of our application to look like. And lastly, throughout this whole process, we narrowed down options that we wanted to add on to our project later. For example, we were thinking of adding some graphs and analytics to allow users to be able to see their progress rather than just looking at the different weights and rep numbers for each workout, kind of making it tangible so they can actually track their progress easier. And for our future work, we plan on in December, for the rest of December, finishing and improving our front end since we already started that part. Finishing our back end in the database, and then in February connecting all of the components. And then March and April, we are planning on kind of adding additional features and refining things that we think need to be cleaned up slightly.
Yeah, I mean, one part of the kind of established workout trackers that we didn't really like is they do have a lot of features. And obviously some of those features are going to be important while some of them are completely unnecessary. So our plan was kind of to build the simple create, do, view framework by February, and then we're going to test it with all of our friends and teamworks, and we're going to be able to realize what features we actually want to need, and then that'll give us approximately 2 months to implement those features, such as maybe downloading a workout or viewing other people's workouts and all this. Thank you very much.
Any questions for Gabe and Max? Right, so the primary feature would be to record and view your past workouts, and so that's going to be a primary feature, and you can share those workouts as well.
Yeah, well, I think we're gonna have it in a way where you can either just like export the data, so I can just like send it to you directly, or there's a way through your application, you'll be able to view my workout. So there'll be 2 ways where you could view it.
Yeah, I think that would be really interesting and useful as well. Like I don't know, I can just look at your workout and have a starting point.
So one of our features was we were thinking of obviously adding the analytics to see track progress, but then if we were able to accomplish that, we were thinking of adding like a login, so each person has an ID, and then I could send my workout to his ID from mine.
Yeah, you need to, so for that, setting up the database and everything would help. All right, thank you.
Oh, okay.
Sorry.
For the workout objects you guys are creating, are you specifying all the workout objects that a user can use, or can like a user, like say I'm doing something obscure that like you wouldn't think of, like, I don't know, maybe I'm like doing like some weird workout.
Yeah.
Can I say like, is there an other option?
Yeah, so
Like,
that's a great question. So yeah, so how it's gonna be is there's gonna be a drop down menu, and there's gonna be probably like 20 or 30 of the most popular ones. Because then that'll allow us to prompt the user for which fields they need to put in, but there will be another option because clearly that won't cover everything. So then that'll kind of just give like every possible field, and the user can input which ones they need, and the rest of them will just be left blank.
Any other questions?
Thank you.
All right, thank you.
Thank you.
Next step is planning companion. I think you can find your. Yeah, this one. That's it. Good.
Hi everyone, today we'll be talking about our senior project AI processing for auto parts equivalence and fitment scoring. This project is working with we're working with a company outside called Parts Tech. So what are we making? So essentially we're making a rating system that if you give me two car parts that we're gonna tell you how similar they are. Say you give me two rotors, and then based on all the parameters it has, its diameters and then its shape will tell you we'll give you a score, how similar, how confident that we believe they're the same. The higher the similarity, the higher the score is. And some background, so as of today, there's more than 250 million cars running on the road in the United States. And those cars are not young, they're old. The average age of the vehicle is 12.1 years, and that number is still expected to grow. Nothing lasts more than 12 years, even still get grows. The US aftermarket auto parts market value is valued to be 17 billion at the year 2020, and that number is still expected to grow. And under this market, there's a lot of third-party players. So a lot of third-party auto parts manufacturers are producing parts for old cars. So you have well-known brands like Bosch and Denso. They're all competing with each other in the market. So how does our rating system help? You will have to take my words for it now, but the data that provided by the aftermarket manufacturers are they're really messy and then really error prone. So because it's manufacturers' duty to keep those data up to date, and they have the freedom to choose to do it or not. So sometimes we will be able to observe some situation like this. So they claim that part 1 and part 2 are the same. But at the same time, they claim that they fit different kinds of vehicles. So part 1 fits part A, B, C. Part 2 fits B, C, and D. Even though the parts are claimed to be the same, it fits different amount of vehicles, and it raised the questions about whether these two parts are genuinely the same. And our system is trying to figure out, okay, based on this situation right now, it looks like it's gonna be the same, but we're not really confident about that. So we want to give a score that reflects that. Yeah.
Right, so talking about the process and methodology, the first thing that I want to talk about is access to data. So since we're working with PartsTech, an external company, so we got our access to data on November 8th. And basically, these are the two main standards that the aftermarket auto market takes into account. So those are ACES, which is Aftermarket Catalog Exchange Standard, which is basically like a main data set. And then the other one is called PIES, which is Product Information Exchange Standard. So PIES will have more information on the product attributes, like what are say diameter or depth and all those things. And ACES is the one which connects it to vehicles. And under PIES, we have 4 different sub data sets: PCDB, QDB, PCDB, and PADB. So as of now, we have access to all of these. And on top of that, PartsTech provided us with a file, like a JSON file, which we call it as vehicle to VCDB relation, which kind of maps which rotor or like which part fits which many vehicles, but only on a very preliminary basis. So we'll definitely be extending the work that they have done on vehicle to VCDB relation. But yeah, this is the data sets that we will be working with. And the second point on process and methodology that we all agree with is the data is super messy. And 2 main points that I want to highlight here is some rotors have like detailed parameters. Like if you look into the first picture there, the first snippet there, you'll see something called outside diameter right over here. So we found that for the same rotor, so these is for disc rotors, for the same rotor, like one rotor might have outside diameter, but other rotor might not have it. So we'll be working in finding out common attributes which we can, kind of base our results on. And the second main finding on this one was the note section. Manufacturers are not obliged to put every data very properly. So we found that they tend to put everything squeezed up on the note section. So in the second snippet you can see note over here. So everything is squeezed over there. So outside diameter is there, and we don't even know like which exactly is outside diameter. So the data is super messy, and like we have already started the data cleaning process on this. The third thing, and this is one of the important slides that would kind of explain our approach to solving this problem. So PartsTech wanted us to make a microcluster. So what microcluster is basically looking into two different parts, comparing those parts, and then putting those parts in a cluster. Like if they are kind of similar, then put it in one cluster. If they're similar in terms of say different attributes that they have. But when we dive deep into the data, since I already mentioned, like they don't have common attributes. So looking into microcluster would not be very helpful, because we were thinking of initially having an axis, like looking into the numeric points and then having axis according to that. So if a part will have say 8 attributes, and if another part has say 15 attributes, then we'll have to leave that 7 attributes to come up with a scalable cluster. So which is quite not feasible with the data that we currently have. So we talked with PartsTech, we communicated well, and then we will actually be starting off with macro cluster, which we'll talk in a bit. So micro cluster is there, but still macro would be the first thing and the main thing that we'll base our results on.
Okay, so as Penny mentioned, macro cluster actually provides a lot of useful insight. So what is macro cluster? It is just a vehicle and parts linkage table. Say I look at their part 1, and then it says that it's car A, B, and C. And then, okay, then I in turn is looking to one of their cars, say part B, and then I found out, okay, other parts also fits part B. So I put out information about the second parts, and then I was able to get the list of what other cars that part C fits. And then doing this recursively, I was able to get a table with all the linkage from, like, say, whether one parts fit in another vehicles. So this table should give us a strong signal that some misdocumentation might have occurred. Even though it looks like all 3 of these parts would fit a common vehicle, but there's something missing here. Is there one of the part doesn't fit part B, which is fit by 2 other parts, and there's a lot of missing informations which we would expect that it to appear. So we want to come up with an algorithm that can automatically detect this mismatch, and then thereby influencing our confidence scores with the data provided by the company. So moving forward, our plan for the future is we will have to come up with an algorithm that can generate the score based on the macro cluster that I just showed you. We'll be looking at this picture. If I want to compare part 1 and part 2, they look similar. These 2 parts look similar, but the existence of part 3 and the existence of these 2 missing informations will give us a signal that, okay, this part maybe looks similar, but it's not trustworthy enough. So maybe get a 70 score or even lower. And then we will dig into the micro level. We will pull in information about those 2 parts, all the detailed parameters like what is the diameters, how many screw holes on the rotors, and then we'll come up with a micro level score. Combining this 2 score will give us the end result about how confident and how similar these 2 parts are, and how confident that we can make sure they are similar.
Right, so just to give you a rundown of what is needed and what we have done, so we are familiar with the data now. We know what PartsTech is expecting, and we also negotiated on the deliverables that they are expecting from us. So these are basically the 5 things that we will be doing. So first is we have already started on building an algorithm for the macro cluster, for which we need a database which has like rotor to vehicle linkage, which the work on that has been started. And then once we have that, we'll calculate the macro score. Initially, PartsTech wanted us to start with micro and then go to macro, but digging into the data, we found that the other side would make more sense. So we'll first start with macro, and then on the third point, we'll do the same thing for micro. So micro level data cleanup has also been started, and same algorithm could be used for micro as well. And fourth would also be the micro score. And then the last step would be kind of like a dashboard so that, anyone in PartsTech can visualize results, or anyone in PartsTech can, in a way, look into things easily without diving deep into the data. And the timeline would be, so right now, December, we have a pretty much working data set on vehicle to rotor linkage. So we'll continue doing that, and then we should be done with vehicle rotor linkage table by December. And in Jan, we'll be looking into cosine similarity. So that will be the main method that we'll be using for scoring. And then we'll be implementing that on macro first in January. And the whole month of February is for micro, because we believe that we'll need a lot of time because of the anomalies in a lot of different attributes and anomalies in the micro data set. And on March, we'll start on visualization for rotors, and we'll be doing visualization and final score calculation simultaneously, which should not take a long time. And if time persists and if everything works okay, right now we are doing with disk rotors. So in April, we plan to, implement the same model with some other data, some other parts, like it could be any other different parts, but we are aiming to be like Axis pipe or something like that. And May would be the time when we'll be delivering our deliverables to PartsTech. And that will be like a final touch or any other attributes that the company would want us to add. So this is a general rundown of our project. So any questions, comments? Thank you.
So are you mostly using a classical machine learning approach? Are you mostly using deep learning, or is it some synthesis you're mostly using?
Great question. As of now, we're using the classical deep learning, machine learning. So as of now, we don't have deep learning components.
What kind of tech are you using, like packages wise and like language and such?
So basically, right now on the data preprocessing, it's Python, and so they gave us all the data in Access, and then communicated with JSON. So basically, a lot of JSON splitting and Python.
Oh, but like for the machine learning side, like what libraries are you thinking?
We might use something on Scikit, but not sure on that. Yeah, if we decide to work on the, like what I mentioned on the node section, so if we have to like really dive deep on the node section, then we will have to use some NLP, but we are not yet sure how beneficial that would be. So that's the main tech.
Thanks.
Mhm.
Any other questions? All right, thank you. Next up is George. Okay. You have a PDF link. You have a link. Let's see. Did you send a doc?
I did.
Sign in. Yeah, well, it looks like you have to sign in. Then back on. Seconds.
Hello everyone, my name is Taka. This is George. Today representing our nurse scheduling tool, which we're developing with Emerson Account, a healthcare startup. So the traditional approach of creating a nurse schedule have a lot of inefficiencies, and this is mostly because they've been working with paper as well as spreadsheet method to create to generate a schedule that captures the requirement of the hospital as well as the preferences of the nurses. And this is one of the example of the spreadsheet method. As you can see, you have each day and then different number of nurses, and they have different availability. And so the the schedule coordinator have to go through each day and see who's available and assign each of them manually. And this process is often time consuming, tedious, and often leads to suboptimal results. So ours, they're scheduling to trying to solve these inefficiencies by eliminating the time spent on scheduling through automating the shift assignments. And our algorithm will generate a more optimal schedule by meeting all those requirements of the hospital, as well as maximizing the satisfaction of the nurses. And we also provide increase the transparency of the schedule through various metrics such as number of shift switch made and the number of the total experience level of the nurses for each of the shifts. So the way our nurse scheduling tool works is we'll have input provided by Summer Health. These will include the preferences of the nurses, as well as information of the nurses, including whether they're full-time or part-time nurses, whether they're nurses who are in charge. And using those information, we will generate a schedule that meets hospital requirements and that maximizes the satisfaction of the nurses using their preferences. And finally, we'll have a web-based analytical dashboard that will display the generated schedule and the important metrics that I described in the last slides. So the nurse scheduling problem is a well-established problem. It's very complicated, and there are many research done over this field. So there are many approaches to solve these problems, and these are the programming techniques that we looked into. So integer programming is that you given the constraints such as the maximum and minimum number of nurses required per shift, and we use that and the preferences of the nurses to create an optimized result using a solver. And constraint programming is that you given a hard constraint, it will generate different schedule that satisfies all the requirements. And then evolutionary programming and variable neighborhoods are both optimization techniques where it makes small changes to the given solution and see if we can further improve the given solution. And lastly, the greedy approach, which is the approach that we're working on right now. It just continuously makes the next best choice.
So for all of the algorithms that we just look at, they're all working on constraints, and M7 has some constraints that we have to work with. And the first one is dealing with like nurse preferences. So each of the nurse, every single nurse has to give like when they're available, that they provided that they want to be scheduled, and also like when they're open. That's like when the nurse coordinator or manager is making assigning shift. You can move some nurses around and see if anyone that's open can be scheduled. And then unavailable, that's mean don't schedule me. I have something to do, maybe school, or I'm on vacation, something like that. So with hospital rules, these are some of the requirements. So requirement for nurses, if you're a full-time nurse, you're required to work 13 shifts for the entire month. And part-time, that's about eight shifts per month. So basically, roughly, it's about for full-time nurses, that's like 3 shifts in a week, and then like 2 for part-time nurse. And then with that shift requirements, so these are kind of hard constraints. These are constraints that must be met by the algorithm. And the first one is the minimum of nurses. There should be a total of 3 nurses per shift, and a maximum of like 5 nurses. That's kind of a soft constraint, so it doesn't have to be met. And then the last, this third one is a charge nurse. This is a nurse with like a particular set of credentials. That's mean he or she can oversee the rest of the nurses and also the entire shift. And then the last one is the number of consecutive shifts. A nurse is not allowed to work more than like 3 shifts in a week or in a row, something like that. So our progress so far, we look at the hard and soft constraint, we define those, and then we also look at the research papers that are dealing with this problem. And also, right now, we're working on the algorithms, like a greedy algorithm that satisfy all the hard constraints as well as some of the soft constraints. And then one of the tricky thing about this algorithm is that how do we deal with fairness? Let's say we can assign maybe a particular nurse, like maybe the shift that they ask for, and then basically give up another nurse like all the open, preferences. So we try to also think of like how can we make the algorithm fair enough to balance it a little bit. So this is the outcome of our grid approach. If you look here, that all 3 nurses per day. This is the weekly schedule. We have 3 nurses per shift, and also no one is working more than 3 shifts and in a single week. And if you look at this row here, non-charge nurses here, basically like all of these nurses that were scheduled are not like charged nurses. So, and if you zoom in a little bit, you can see the data that these are the nurses that we scheduled 0, 5, 7, and 8, and all of them. So 0 mean they're not they don't have that credential, they're not charged nurses, and 1 means that they are charged nurses. So we look at them, those were scheduled at the same time, and that constraint was not met. So what do we do in that case? We look ahead and try to fulfill the soft constraint. That's like the maximum number of nurses. That's like 5. So when we look ahead, we find more nurses, and one of them was like a charge nurse. So we scheduled it, and that requirement was met. And if let's assume that there wasn't a charge nurse when we look ahead or when we try to fulfill like the soft constraint. So what we can do is like M7 is like you can make one of them a charge nurse basically. So by default, make one of them a charge nurse so that they can oversee the shift.
So for our future work, there are several steps. First one to generate some randomized preferences input. So it provides more various input so we can solve various edge cases as well as different cases. And then we also want to create a validation system that takes soft constraint into account. So we want to make sure that when we compare different solutions, we know which one satisfies more of the nurse's preferences. And then we also want to test various approach to optimizing the scheduling algorithm. Because there are various solutions and we're not sure at this stage, still not sure which one might be the optimal one. So we want to test the options that we have and see which one might work best. And then lastly, we are going to create a web-based dashboard that displays the schedule. So for the timeline, during January and February, we want to work on the implementation of the algorithm and the testing various algorithms. And in March and April, we would like to have a finalized algorithm and trying to refine that particular algorithm as well as working on the web-based UI.
So these are our sources. Thank you.
Thank you. Any questions? So can you give me a little intuition? How would you implement the fairness of scheduling?
So right now, we're probably going to use the satisfaction score, and we might get an average of the satisfaction score, or we could use like a geometric average. So
what is a satisfaction score? Do they enter a satisfaction score, or is it a utilization?
We'll see like how many preferences of the nurse.
Okay. So that kind of tells fairness? How many you're trying to even out the number of preferences per person?
Yeah.
Okay. Okay, thank you. All right, that's all. We'll have that's all for Martha and George. We'll have Ian go next. Is this yours? No.
Yes. Okay, so my project is a GPS speed limit monitor. I'm gonna introduce you to what it is briefly. Basically, I want to allow parents to monitor their children's driving behavior. And the key features I want to have are you want to alert the parents when the speed limit is broken. And time permitting, also alert the parents when they accelerate too fast or brake too slowly or too harshly. As far as the technology is concerned, using Swift for a main iOS app for both the parent and the child. It's the same app. For the server, I'm going to use Vapor, which is a Swift server. It's a server written in Swift. And then for the database, I'm gonna have to figure that out later. So a little background on my project. Speeding is a factor in 29% of all fatal car accidents. And despite speeding being so dangerous, 45% of drivers drove 50 miles per hour over the speed limit in the past month. So despite speeding being dangerous, it is very common. And so the normal deterrents of speeding, like speeding tickets or points on your license, are just not enough, and that's where my project steps in. So the purpose of my project is to see if so prevent accidents, prevent fatal accidents, prevent speeding tickets, prevent any kind of dangerous driving habits, and most importantly, gives their parents peace of mind. So essentially what this should be is the main page of my app, which is a map that tracks the user's location. Right now, it's just set on a loop going up and down Summit Street. One way it breaks the speed limit of 30, the other way it doesn't. And it displays every second the user's speed. So you can navigate from that main page to the second page, which basically has a list of incidents, which are right now it's only displaying the maximum speed of per incident, which it's going back and forth, so it's the same number. But also in these incident objects are the location of the incident, so where that took place. So the first part of my project was simulating movement. So there are built-in processes in Swift that simulate like a freeway drive, but it's variable speed, it's variable location. So I needed to use something called the GPX file, which takes a list of waypoints, which are just locations and times. So you can see if this time starts at second 45, this time this location starts at 47, so it just moves in between that location. So this is just going up and down Summit Street. It just gives me more control for my project. So the main view, which you should have seen, just has a link to the incidents view, a map with the user's current location, and a string, which is just the current speed. And the incident view is just a list of incidents, which is just an object I created, like a structure. So the most important object in my project is the location view model, which basically handles all the logic and holds all the variables for both views. This object is also a CL location manager delegate, which allows me to call special functions associated with the user's location and the location manager object in Swift. So as you can see in the main view, I have the location view model as a state object, and I passed it as an environmental object, which means I can use the same object in subsequent views like the incidents view. So that's where my incidents array is as well.
So for the CO location manager delegate, you can call functions like this, like request always authorize, which obviously requests permission to use your location. And this is by far the most important function that it allows you to call, which is a location manager function. It passes an array of locations to the function, and it updates the locations array when at once a second with new locations. So in that function, so basically, you're supposed to be able to access the get speed function from the location manager. But if you use a GPX file, which is like simulates your own movement, that doesn't work anymore. So I had to go online and figure out how to get the kilometers from 2 locations in latitude and longitude. So since this function is called every second, you can just take the miles distance and multiply it by 360. And then this is the main logic for the incident. So the current speed is, if the current speed is greater than 30, then you update the maximum speed with that speed. And then once it's over, once like the incident is over, then the incidence array is updated with that location and speed. So you might be wondering why I'm not doing the current, like the speed limit of the road yet. So there is a Google speed limits API and it's very easy to use, but it's pretty expensive. So I didn't want to like have that for testing for an entire like 4 months. I think it would be quite expensive. So I'm going to do that at the very end. But just to demonstrate how it works, there's an example website here, and I have 2 points from Summit Street. Essentially, you just put 2 points, 2 or more points, and then it'll find the road you're on and give you the speed limit. So it's not very difficult to use or understand. So the next steps, I'll go over them briefly, but they're basically the server side of the program, the authentication side, and then the user interface. So for the server side, it's very simple. Essentially, I just want to send incidents of speed, like a speed and location object, to the server, put that in the database, and then from verified users, be able to return a list of all their incidents. As far as authentication is concerned, this is probably going to be the most difficult part of the project, but essentially I want to allow users to connect with one another and from their login be able to view, one person be like the monitor who can view the other person's incidents and also alert them whenever these incidents happen. As far as the interface is concerned, it's not very complicated because most of this application is going to run in the background. So there'll be a login screen. And essentially one screen to view your incidents. And then probably another screen. I haven't thought about this much yet, but probably another screen for linking 2 users together, however that happens. As far as the timeline is concerned, so I split it up into 4 months. So essentially the first month I'll be setting up the database and server and just making sure that works. Next I'll be sending the data from Swift to the database and back. And then the third month will be all authorization in the login screen. And then finally the user interface and the Google Maps API. Any questions?
Will the parents actually be able to see where their child is, or you'll be able to see when they have it?
I was thinking just the incident. So like they'll see the location when they broke the speed limit and like constantly be tracked.
And like how, everything like how easy, like will it always be tracked, or like the student need, or does the child need to go on the app, or like?
I think it'll just run in the background, essentially.
Thank you, Ian. Other questions? We have our last speaker, Colin. All right. Yeah, good.
Okay, so last, I'll try to keep this brief, but I'll go through everything.
Just an idea recap, building a public web app called TradeBot. That's basically just gonna ask the user a series of questions regarding their investment profile, and then basically show them a ranked list of algorithms that I will have tested. I guess just some of the inspiration for this was, I'm an econ major as well as computer science and an interdisciplinary major, so I wanted to do something that, combined the two. And then, I don't know, when I was trying to like research algorithmic trading this summer and like sort of like get a feel for it, I realized that like all the sources that I found either were just like super in depth, like too in depth on like one specific aspect of the whole process, or they were just behind like a really giant paywall, like hundreds of dollars sometimes even. So I'm really just making a tool for people who, want to do what I did, but just basically, learn more about algorithmic trading and just sort of like how it all works and just give them all like the information for it. So before I get into the specifics, I'll just go over a brief timeline, basically just starting with the fall semester. Things that I've already done are in blue. So I did a lot of research. It was super research heavy for the beginning of it. Took a broker API course. If you're not familiar with what a broker API is, that's basically just fully functional brokerage account, but you can sort of use use text, like a text file like Python or something, and like just directly apply it to it. I built the user interface, still not totally finished, but I'll show you guys a picture on the next slide of what I have so far, or 2 slides. I'm in the process right now of testing and fine tuning the different algorithms that I researched. And then, in the spring semester, I'm going to have to do the back end of the web app, the logic for that, web app's key feature, which is the algorithm that recommends the other strategies. And then just, at the end, maybe just clean up some finishing touches. So like I said, what I've done so far, I took a Udemy course on interactive brokers. I also had to learn about Alpaca, which is the yellow one on top of that. They basically do very similar things. They're both broker APIs, but there were just some issues with like IBKR offers like a more comprehensive suite of features, but it was also like you have to pay for it. So I don't know, just sometimes I had to use Alpaca in the beginning, and I'm just going to use IBKR for when I'm like really trying to get results. I implemented the front of the web app using JavaScript, so that was something that I was totally unfamiliar with, but I learned basically just by using, Angular website is a great resource where you can see your web app in real time as you're editing it. And it just kind of tells you like, if you're trying to add something like this, like you maybe use these methods or these commands. And then, like I said, I did extensive research on, time series statistics as well as, viable strategies, and I'll go through one of them later, the Arima-Gark model. So here's a picture of my user interface as it stands right now. I really wanted to like do an actual demo, but I just couldn't really make it work with like a link on the PowerPoint. So basically once the user hits start, it's going to show them this like drop down menu of a bunch of questions. These are the initial 4 I'm working with right now, but I think eventually I might add a couple more when I'm writing the algorithm for the key feature. So yeah, basically just, they're going to have the question, just some, options for them, and then just like a brief, blurb at the bottom, just saying kind of like, why is this important and like, how is this going to affect like your recommendations? So here's just some code. This is just an accordion object they use for the drop down menu. Nothing too crazy. It's just like one of the things I figured out, just playing around with Angular. Let's see. Here's just some more code snippets. This is my main HTML file or HTML script on the left. Basically just like, calling, other sort of HTML files. And then on the right, that's just a constructor for the app component, basically saying, display fields basically is when I want to show the drop down menu, and that's going to be on the first click of the button. And then, eventually underneath that drop down menu I showed you, there's going to be a list of rankings for the algorithms, which, a similar just Boolean value for display ranking. And then briefly, I'll just walk through a little bit of the Arima-Gark model. This is like probably the most complicated strategy I'll be testing. It's really just a combination of a few different regression models. The autoregressive model is basically just an extension of a random walk model in which the prediction is equal to just like some coefficient times whatever the last observation was. It's basically an extension of that. Instead of just using the first previous day, it's actually going to use like, 5 previous days. The moving average model captures the white noise, so basically the residual or anything that like was unexplained by AR, autoregressive model. And then like this is kind of just an equation of the combination between this is, you know, part of the AR model, and these would be just like the residual, and then this would be just for the moving average model, white noise. Basically every day the logarithmic differences in the returns from the index from previous days are used to fit the models. I had to use log difference to make the time series data stationary, basically just like removing seasonality and the long-term trend from the you know, performance. And then you know, this information is passed to the AIC, which is a bit of a black box. I'm not entirely really sure how it works. Like the sources I read didn't really dive super deep into it, but basically it's going to test, you know, something like 20 different versions of the ARIMA model with different, you know, parameters, pretty much just like different number of days that it's going to be regressed on. And it kind of just punishes them for overfitting. So like, kind of just like picks the best fitting one. And at the end of the day, it's going to, you know, recommend you short or buy long security based on what the prediction is. I won't go through all this again, but this is basically just some of the logic for it. You know, you create a vector for forecasts that kind of creates the moving average aspect of it. The secondary loop that sort of, you know, passed all the information to the AIC, you know, provide the best fitting model, and then it just, you know, provides the recommendation. So what I'm doing now, this is kind of the stuff that's in progress. Testing and fine tuning the algorithms. Using pandas and matplotlib, basically just like have data viz and just kind of just like show the results. And like why this is important for me is because this is going to help me to find the logic for the key feature recommendations. Basically I have to like use the test results for this, sort of evaluate them. And then I'm using the QS trainer and backtrader libraries just for like loading historical data. And then I just put a picture of Yahoo Finance there because they're actually like a great free source of historical data for pretty much like any ticker you can think of. This is just like a function that I found in one of these libraries that basically helps with loading data. I'm not going to go line by line here, but basically if you look right here, you kind of set the parameters for what you're looking at. Some of the things that I'm really interested in like tweaking are just like, you know, the candle length. If you're not familiar with like a candle chart, it's basically like a very common metric used by people in finance to, you know, track open close prices as well as like price fluctuation over a certain period. So that's, you know, one of the hyperparameters I'm playing around a lot with. There's plenty more. And then next steps in Spring work, I just have to build like the back end of the web app is one of them. I haven't really decided what I'm going to be using for the server. I'm still kind of doing research on that, but I know Node.js or SQL are kind of what I'm looking at right now. I have to continue to test and fine tune the algorithms, basically just like what I said in the last slide. And yeah, just to find the logic for the key feature. Like I said, I kind of have to do all the tests first before I can do that, just because like the algorithm is going to be using the test results. So yeah, that's sort of what I have in front of me for the spring semester. And then there's my references.
Any question? All right, I have one.
Sure.
So what data does the brokerage API give you? The historical data or the current data?
So that's just like both, kind of like I can use both. So the broker APIs are more, I guess, for like live data, but they also can just access like the records, historical stuff, and through Yahoo Finance, and you just pretty much, I don't know, you just put like a ticker in, and basically like as far back as it goes, they have a bunch of different data, like closing price and opening price, and sort of like how it fluctuated in between that period. So,
okay. And so what you can do is have the bot study the historical data separately and use the brokerage API for only doing the trades.
yeah,
that would be probably faster than using the API to have the data, because the data needs to be trained on, right? You cannot.
Yeah.
And that needs to be done before the analysis.
yeah. So that was like this one, like this function I was showing you, like this is like not from a broker API. This is more like I could just do this and just like feed it like information from Yahoo Finance.
Okay.
So basically exactly what you were just saying. Yeah.
Okay. That makes sense. All right. Thank you. Thank you. Thank you, everyone. That concludes our senior presentations. good work, and make sure that you submit your project report if you already haven't done so. And best of luck for the break. See you next semester. Thank you.
Take the cookies with you.
Yes, yes, we don't want any cookies here, so take it. Handshake, handshake or?
No. The. One centric already.
Okay, okay, I'll look into it.
Like the thing I did for,
Stop
like to
it.
get it,